Good morning, grade 10s. I hope you enjoyed your long weekend and are ready for a new chapter in a new week. So today we'll be looking at solving basic mathematical problems using Delphi. And specifically today, we are going to look at mathematical operators, and that is module 4.1. Now, there are not any new mathematical operators because in term 1 we've already introduced the operators of div, which is an integral division, as well as mod, which figures or calculates the remainder of a division. So without any further ado, let's have a look at the textbook and let's go through that. I'm going to be doing some activities with you, and I will also highlight the activities that you have to do on your own. So today we're going to look at unit 4.1, and we're going to skip through all that introduction stuff. Okay, basic operators. This is grade 1 stuff, and then we've already covered these two. So addition, subtraction, multiplication, real division. Real meaning that the others are not fake, but real means it's of data type real. And then we have an integer division, which is whole numbers, and then you have the modulus, which is the remainder of a division. So if we do a long division, we have, the remainder is the modulus. Okay, activity 4.1. Wow, that was quick. We're already at activity 4.1. And I'm going to do this one with you, or at least a couple of them, so that you can see what is actually required of you. So I'm going to write the answer in the book here. So 8 plus 7. So we have to indicate whether the following expressions are valid or invalid. If they're valid, write down the answer to the calculation. If invalid, give a reason for why you say so. So I will just say here V for valid, and obviously that results in 15. Oops, I shouldn't have done that. Let's rather do this. Okay, 9 mod 5. Is it true or not? It's valid. How many times does 5 go into 9? Once. So 1 times 5 is 5. 9 minus 5 is 4. So the answer would be 4. Okay, then we have the second one, or the third one. 4.3 div 6. Is this valid or not? I'm going to say NV for not valid. Why is it not valid? Because we cannot, there's no integral part of dividing 4.3 by 6. Because it is a decimal. Right. Then this one, 9 div 2, is valid. How often does 2 get into 9? 4 times. The remainder would be 1, but div is 2. Then 6 mod 9, that is valid. How many times does 9 go to 6? 0 times. 8.5, again, invalid because it's an integral. It has to be an integral division. This one will work out, etc., etc. These ones will work out as well. All right. This one would work out. 6 mod 9 would be 6, the answer. All right. So I'm going to take that away. You can complete it if you want to, but that is simply showing you the different mathematical operators. Okay, order of precedence, bottom-as. So this rule you know already from primary school, and you should know in high school as well, which means, you know, brackets of division, multiplication, addition, and subtraction. So we work out first the brackets, then the, you know, multiplication, division, diff, and mod, and then second level from left to right, whichever comes first, and the same with the addition and subtraction, whatever comes first. So example 4, 2 plus 3 times 26 divided by 16 minus 3 in brackets minus 5. So we first calculate 16 minus 3, which is 13. So there this corresponds. Then we will first from left to right, so we have a multiplication as well as a division. So we first calculate this, which is 78. Then we do our division, which is 6. And now again from left to right. So we have 2 plus 6, which is 8, and then minus 5, which equals to 3. So over here, we will now, I will do the first one with you, and the rest you will do on your own, and then we're going to look at trace tables. So first, brackets. Now we look inside the brackets. We have a multiplication, so we'll do multiplication first. So 4 times 4 is 16, plus 12 is 28. Diff 2 would be 14. And you can do the rest yourself. I'm going to take the highlighter away. Okay, we are going to look at two things now. The first is a trace table, which allows us to keep track of the values that is stored in variables. Remember, variables are little containers that can change throughout our program. And to track or trace mistakes or errors that could have crept in, we will make use of a trace table which traces the values of variables line by line throughout our program. And then we're also going to look at IPO tables, input, process, output, and especially the input, output, or input, process, output tables you are required to use in your PET. So those are two very important things. The trace table will be asked of you in theory exams, I guarantee you, all the time, from now until you are in matric. So the trace table, you have to identify all variables, create a table with a column for each line, and then a separate column for each variable, and a column for the output. So follow the code line by line and write down the new value of the variable that changed. So we have an example here of a person who buys 2 items. 10% discount is given to the total price. Then the VAT is calculated and added to our total, and then the total is calculated, etc., etc. So we have the different lines. We receive, you know, the price for product 1, the price for product 2. The total of it is both of these prices together. Then we calculate the 90% of that total. You can either have total minus, you know, total times 0.1, or you can do it like this because it's an easy calculation. Then we calculate the VAT, we add, you know, our total, in our VAT, and we display the total. So in line 1, we receive price 1, that's our variable of real data type. In line 2, we receive price 2, which is also real. Then we add together in line 4 the total changes, because we only want 90% of that total, which is now 27. Then we have a new variable that enters the scene, which is called VAT, and we calculate VAT as total times 0.15, which is 4 Rand 5 cents. We now add that to our 27, which is 31.05, and in the end we display the total in our rich edit or memo or label or whatever output component we use. Here's our algorithm. You can check that which corresponds with these things. So this would be more or less pseudocode. We have our trace table, and then we have our real code. You can see all the variables that were declared, all of them reals, and our algorithm to calculate our total. Okay, then using an input processing output IPO table to plan a program. So this is basically a planning tool, and hence we use it in our PAT phase 1. So you determine all your inputs, all your processing, and all outputs for your specific calculation or algorithm that you have to complete. So let's look at a simple program that changes a degree Fahrenheit into a degree Celsius. So our IPO table looks as follows. Degree Fahrenheit is the input. The processing is our formula to change our degrees, and the output will then result in a degree Celsius. And here we have our program, our code that does exactly that. So if we would have to make a trace table, we have a column for the line numbers, a column for our two variables, and a column for our output, and we would assign the variables, do some processing to it, and then output the degree Celsius. We have another example that you can look at for 3 friends, and they share some sweets, ratio 3 to 4 to 5, which is a total of 12. So if you want to share, so you enter a number of sweets, and you want to know how much sweets does each and every one get, and there will be a remainder as well, depending on if the number of sweets are divisible by 12 or not. So if we enter, for example, a number of 25, that Tom will get 25 times 3 div 12, etc., etc. So our number of sweets is the input. And then we do all these processes in order to find out our results, which will be on the output. Here's our algorithm. You can have a look at that. And here's our trace table, which again has all the different variables that could possibly be used in our program. Our line number of sweets, and then the results of our calculations, and then we will display that in our output, and we'll stop it. So activity 4.3, you have to do theoretical answers for these, and then you have to write a program that will do all these calculations for you. Okay, that's exciting. Then we have activity 4.4. Unfortunately, also a little bit more theoretical. And activity 4.5 also theoretical again, and you continue and you create, you complete the trace table for that. All right, and that's it for today. I hope this made a lot of sense. So remember to like this video, to subscribe if you haven't done so yet, and leave me a positive comment. You guys rock.